Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and today we're gonna jump right into our Pac-Man tutorial because we have got so much to cover. Because we're gonna be creating our ghost script, and our ghosts are gonna be basically autonomous. They are going to just move around all by themselves, and yeah, so that's gonna be our ghost. Our ghost is gonna just go from node to node to node to node to node, and he is going to just be chasing Pac-Man around. With that, we're going to talk about a few things. Got a few talking points here. Okay, so there are a few things to consider when writing this script. All right, so first of all, we've got different modes of operation for our ghosts. Okay, if any of you are familiar with Pac-Man and have played it, which I'm hoping that you at least have had a chance to play Pac-Man, you may not have noticed all the little things that happen with these ghosts as you're playing the game because you're constantly just trying to stay out of their way and you're just trying to eat your pellets. So, what one of those things is that there are modes for these ghosts, and there are three modes. Okay, there's a chase mode, which is when the ghosts are actively chasing Pac-Man. There's a scatter mode. That's kind of like when they give Pac-Man just a short little break and they kind of just go away. They just start to go somewhere else. They're not chasing Pac-Man at the particular point in time. And then there's a frightened mode, and that mode is basically when Pac-Man consumes a super pellet, the ghosts, they become frightened and they just start to run away from Pac-Man. Okay, so those are the three different modes. Okay, and the way that these modes work is that, especially between the chase mode and the scatter mode, okay, the scatter mode actually starts with 7 seconds. Okay, when the game starts, the ghosts go into scatter mode, and then as soon as those 7 seconds expire, they go into chase mode for 20 seconds. Okay, and then after that, they'll go into a scatter mode for 7 seconds, and then another chase mode for 20 seconds, and then a scatter mode for 5 seconds, and then a chase mode for 20 seconds, and then another scatter mode for 5 seconds, and then they switch to chase mode permanently after that and are continuously in chase mode. Okay, so another thing to consider is that the ghosts themselves, they can never reverse direction to try to chase Pac-Man when they're in chase mode. Okay, they only reverse direction twice. They do this when they move from chase mode to scatter mode, or when they move from chase mode to frightened mode. They can then change directions because they have to go the opposite way. Okay. So in the actual game, there are also going to be 4 intersections at which these ghosts are not allowed to move upwards. And I believe that these are right here, so they can't go up from here. And here, they also can't go up from here. And I believe from here, no, here, one of the other locations, there's a couple of spots where they're not going to move up, okay? And we're going to define those later. Probably not in this tutorial, but maybe the next. All right. Let's see what else I've got here. We're not going to get into the individual ghost AIs in this tutorial. This tutorial is kind of just to flesh out the actual ghost script to get the general AI of these ghosts started so that they can actually move around the board. Once we've got the ghosts moving around the board, in the next tutorial we're going to look at implementing individual AIs for each ghost because each ghost does something a little different. Okay, so we'll get into that. But right now, let's go ahead and get started. And, we need to start coding these ghosts. So the first thing we're going to do actually is we're going to drag in just one ghost. Okay, so I'm going to grab Blinky and I'm going to put him right here in the graphics. Okay, so I'm going to just grab him from here. And if we go into graphics, if we then go into here, we'll see Blinky's here. So now if we take Blinky and we just kind of drag him into our game, he's extremely tiny. And that's because we still have to actually set our pixels per unit. And I think we're going to 32 if I'm not mistaken. Nope. Let's go to 16. Looks about right. Or where are we at with Pac-Man? Yeah, Pac-Man's at 16. Okay, so 16. I'm good with that. So now we need to move him into his little ghost house. And actually, you know what? For now, we are just going to vertex snap him. Actually, we need to do kind of the same thing. Let's see, where's Pac-Man? Pac-Man is at 15 on X and 7 on Y. Oops. So we'll move Blinky to 7 on the Y-axis, and he won't be at 15. He'll put him over here at 9. Alright, what I'm also not going to get into in this tutorial is actually the animations of the ghosts, because their little things here, they kind of move a little bit. Their eyes will orientate based on which direction they're actually going in. So we're not going to be doing that in this tutorial. This tutorial is all about getting the ghost moving, because right now, if we press the play button, our ghost just kind of sits there. Okay, so let's go ahead and make a prefab of our ghost. So let's drag from the hierarchy into our prefabs folder. Okay, so we've got ghost. Let's rename this to actually ghost with a capital G, because I'm OCD like that. And then in our prefab, with our prefab selected, we're going to add component. We're going to create a new script, and we're going to call it ghost. We're going to make sure that the language selected is C#, and then click create and add. So now that we've got our script created, we're going to go to assets because it puts it in the root folder, and we're going to take this script and put it in our scripts folder. Now in our scripts folder, along with our other scripts, we've got our ghost script. So let's go ahead and launch that. Alright. So, and just like with everything else, all scripts are created equal. So, the first thing that we're going to start with is creating a few variables. One thing that we're sure we're going to need is a move speed. So we're going to go ahead and create a public variable that is going to be a float, and we're going to call it move speed. Okay? I'm going to set that equal to 3.9f. I think, let me see where we've put Pac-Man at. So Pac-Man's move speed is actually 4. And the ghosts are only slightly slower than Pac-Man. So we're going to keep the ghost speed at 3.9. And we can edit that. We can make it 3.95 or 3.99. That would make them extremely slightly less faster, or less, yes, whatever. A little slower than Pac-Man, okay? And you guys can set these up however you like. And I'm not even sure if these are like the speeds of the original game. I kind of just set them as I thought they would be, so I don't know if they're right. So let's move along, and we are going to create we're going to create our starting position. So we're going to use node, the node class, and we're going to starting position. And then we are going to create our timers, okay? Because we need to know when we switch modes, okay? And there are going to be 4 modes total, okay? And for each mode, there's going to be a scatter mode, a chase mode, scatter mode, chase mode, scatter mode, chase mode, scatter mode, and from that point on, we're going to be able to set individual timers for each of these. So I'm going to create a integer and call this scatter mode timer 1, and that's going to be 7 seconds. Public and chase mode timer 1, and that's going to be 20 seconds. And then an integer for scatter mode timer 2, it's going to be 7 seconds. Another integer for chase mode timer 2, it's going to be 20 seconds. And then another one for scatter mode timer 3, and that one is 5 seconds. And then chase mode timer 3, and that's going to be 20 seconds. And another scatter mode timer 4, it's going to be 5 seconds. And chase mode timer 4 is going to be 20 seconds. Okay. So these are all of our timers. And then we need to, in order to know which timers we're going to use, we need to have a variable to keep track in which iteration of the mode we're currently in. So we're going to create a private integer, and that's going to be mode change iteration. And the current iteration is going to be 1, so we'll set that to 1. And then we're going to need a timer to keep track of when we need to change. So we're going to create a float, and we're going to call this mode change timer. We're going to set that equal to 0. Okay. And then we're going to need a way to keep track of which mode we're currently in, chase, frightened, or scatter mode. So we're going to create a enumeration, enum mode. Okay. And it's going to have chase, scatter, and frightened. Even though we're not going to do anything with frightened just now, we're going to go ahead and include it just because at some point we're going to use it. So then we're going to create a current mode. So remember how I said that we're going to start off with scattered mode? So our current mode is going to be scattered. And then we're going to need to keep track of our previous mode so that we know which mode we were at before we changed. Okay, so like I'll get to that, but we need a reference point for that. So previous mode. Okay. And then we're going to need a reference to Pac-Man actually. So we're going to create a private game object Pac-Man. And in order to keep track of directions and everything, just like with Pac-Man, we're going to create private node, current node, target node, and previous node. Okay. These will serve as our location markers. And then we'll have direction and next direction. And these are vector 2s. So direction and next direction. Okay. So now that we've got most of the variables that we're going to be using, and as the script continues to build, we are going to create a few more variables, and that's mostly when we get into the AI of the ghosts, so that we're going to add some more variables to deal with those. But for now, these are the variables that we're going to be using to make our ghost move around. So the first thing that we're actually going to do is we're going to create some helper methods that we're going to use in some of our other methods to move around and do other things with. So the first one we're going to create is to get the node at position, right? Just like in the Pac-Man script. So we've got node, get node at position, and we're going to pass along vector to position, and then we're going to say game object tile equals game object dot find game dot get component game board dot board. Okay. Oops. And we're going to pass in casting an integer to position.x and also position.y. Okay. And then we're going to make sure that the tile doesn't equal null. Alright, so now we need to make sure that the tile that we're on actually has a node component. Okay, so if tile.getComponent node doesn't equal null, right, that means that we actually have a node. And if it doesn't equal null, then we return tile.getComponent node. Okay. So otherwise, if this does equal null, then we're going to skip over all of that and just return null. Okay. So let me just explain this once more. We're creating a game object. We are setting this game object equal to the game object stored in the game board array, in the game board array, at the position that we're passing in of the position that we're currently at. We're checking to see what, okay, we're grabbing the game object that's at that position. Then we check to make sure that whatever we grabbed isn't equal null. And then if it doesn't, we make sure that it actually has a node component, because if it doesn't have a node component, that means that it's not a node, and we shouldn't be getting it. So if it doesn't equal null, then we get in here and we return this. If it does, then we just go out of here, then we break out of this if statement, and then we return null. Simple enough. Okay. So since we've got this get noded position, what we also want is we want a way to change our mode. Okay. So this is just going to return absolutely nothing. It's just going to be a void, and we're going to call it change mode. Okay. And we're going to pass in mode and assign it to m. And we're going to set current mode equal to m, okay, because that's what we're changing our mode to. And then we are going to do nothing else, because that is basically it. That method looked a lot bigger to me the first time, because when I wrote it, there's some other stuff in there that has to deal with whether or not the ghost is in the ghost house and those kinds of things. So we're also not going to create the start frightened mode method yet, because we are not going to do anything with the frightened ghosts. We are going to create the next method, which is the the mode update method. We're going to put that one up here. So change mode and mode update are two different things. Mode update is going to basically work with our timers and determine whether or not the mode needs to update. And then we're going to call change mode from mode update to actually change our mode. Okay. So first we're going to check to see if the current mode doesn't equal mode.frighten. Okay. If it doesn't, we are going to increment our mode change timer by time.delta time. Okay. And then we're going to check to see if our mode change iteration equals 1. Okay. And if it does, we need to check if our current mode is mode.scatter and the mode change timer is greater than scatter mode timer 1. Okay. We're using timer 1 because we're in mode change iteration 1. So if that's true, then we're going to change mode to mode.chase, and we're going to set our mode change timer to 0 so that it can restart. And if the current mode is mode.chase and the mode change timer is greater than the chase mode timer, then we're gonna change mode change iteration. We're gonna set mode change iteration to 2, and we are going to call change mode, and we're gonna set our mode to mode.scatter, and we're going to set our mode change timer equal to 0. Okay. So that basically covers what we're going to be doing for each of our mode change iterations. Okay, so we start with the highest level, which is the mode change iteration. Actually, the highest level is here. If the current mode doesn't equal mode.frightened. Because if we're in frightened mode, then we do not want to change from scatter mode to chase mode, or from chase mode to scatter mode, because if we're in frightened mode, we want to be in frightened mode until frightened mode has completed. Alright? So, and if we're not in frightened mode, then we want our mode change timer to continuously increment with time.delta time. Okay? So, and then what we do is we check to see which iteration of the mode change we're currently in. And if we're in the first iteration, we want to check to make sure if we're in the scatter mode and the mode change timer is greater than the scatter mode change or the scatter mode timer, that means we've exceeded the amount of time that we want to be in scatter mode. At that point, we're going to want to change our mode. Okay, we're going to change it to mode.chase. And we're going to reset our mode change timer to 0. So then the next time this runs, our mode change timer is incremented again. This time we won't be in scatter mode any longer, we'll be in chase mode. So this is going to be true. So if we're in chase mode and the mode change timer is greater than the chase mode timer 1, then we know that we've completed our scatter mode and our chase mode for the first iteration. So then we change our mode change iteration to 2, and we change our mode back to scatter, because that's what we always start with, and then we change our timer back to 0. So then, if we're not in mode change iteration 1, we have to say, okay, well, if we're not in that, are we in mode change iteration 2? Alright? And then, if we're not in mode change iteration 2, are we in mode change iteration 3? If we're not in 3, let's check if we are in 4. Okay. And if we are not in frightened, then we're here. Okay. Otherwise, if the current mode is equal to mode.frightened, then we are in here. Okay? We're not going to do anything in here yet because we haven't created these timers, because we're not dealing with frightened mode just yet. But let's go ahead and fill out these. Alright, so same thing here. So if we do if current mode equals mode.scatter and mode change timer is greater than scatter mode timer 2, because we're in mode change iteration 2, then we change mode to mode.chase and we set our timer back to 0. Then we check if current mode is mode.chase and mode change timer is greater than chase mode timer 2. Then we set our mode change iteration equal to 3. And we do change mode, and we're going to set ourselves back to scatter. And we're going to reset the mode change timer back to 0. Okay? For the third mode change iteration, we're going to say if current mode mode.scatter and mode change timer is greater than scatter mode timer 3. If current mode equals mode.chase, mode change timer is greater than chase mode. Okay. If the current mode is greater than the scatter, if the current mode equals the scatter mode and mode change timer is greater than the scatter mode timer 3, then we set when we call change mode, and we change our mode to mode.chase, and we reset our mode change timer. And let's see what else. Here. So if the current mode is chase and the mode change timer is greater than chase mode timer 3, we change our mode change iteration to 4, and we change mode to scatter, and we set the mode change timer to 0. Now in change iteration 4, since we're now in the 4th iteration, okay, we're just going to go ahead and change if current mode equals mode.scatter, and mode change timer is greater than scatter mode change timer, or scatter mode timer 4, then we change mode to mode.chase, and we reset our mode change timer to 0. We don't check if we're in chase mode here anymore, because once we go to scatter mode into 4th iteration, then we're in chase mode forever, so we don't have to even check this anymore, okay? So what'll happen now is, so we're done with the mode update, okay? So again, this mode update method basically just runs every frame, which means we have to actually call it from our update method. So mode update. And basically this just automatically changes our modes for us from chase to scatter based on our timers here, okay? So we don't really need chase mode timer 4, so we can actually delete that. Because the 4th chase mode lasts forever, alright? So the next things that we're going to need, and these are going to have to do with being able to move the ghost around the board, are some more methods to getting things like, well, here we're using get node at position. We created that, but we haven't used it yet. So the next one we're going to create is get portal. So we need to, because we need the ghosts also need to go into the portal. So get portal, and we're going to pass in vector2, and we're going to call this position. And from here we're going to say game object tile equals game object dot find game get component game board and we're going to pass in our position while we're casting integers, because we can't pass floating point positions in an array. And we're going to make sure that tile doesn't equal null, so that our game object can actually be used. And then we're going to make sure that our block. Okay. So we're going to use, we're going to do another if statement, and we're going to say tile.getComponent tile, because each one of our tile components has a tile, or each one of our tile game object has a tile component. And then we're going to say is portal. And if it is, then we set the game object, we create a game object. We call this other portal. And we're going to say tile.getComponent, tile portal receiver. Okay, so that's the game object that's obviously holds our portal that we're transferring to. And we're going to return other portal. And just in case all of this crashes out on us, we're going to return null at the end of the method. Okay. So this will actually, when the ghosts get to the portal, they'll get the proper information in order to get to the other portal, of course. Alright, So the other thing we need to do is we need to get a target tile. We need to have that method. We're going to return a vector 2. So get target tile. I'm going to explain what this is for in just a bit. So vector 2, target tile was vector 2.0. Actually, you know what? We don't need target tile right now. Target tile is only used for when yeah, so target tiles are something that we're going to use for individual ghost AIs, so we're not going to need that. We are going to need, we're going to need length from node. So we're going to get our length from node that the ghost is traveling to or from. So vector 2, target position, minus vector 2, previous node, dot transform, previous node, transform, dot position. And we're going to return the square magnitude of that vector. Okay. Then we need to know, did our ghost overshoot its target? So overshot target. So float node to target, length from node, target node, transform local position, float node to self, length from node, transform dot local position. Oops. And now we're going to return node to self greater than node to target. So that just tells us if we overshot our target. The other thing we're going to need, all these helper methods here, we're going to need to get a distance, okay? So this is a little method that I created to take two vector 2s, such as position A and position B, and we are going to get a distance as a float between those 2 points, okay? So basically what we've got here is float dx position A dot x minus position B dot x, and we've got float dy equals position A dot y minus position B dot y, and then we're going to just take the square root. We're going to store that in distance, so mathf dot square root. So this is just a standard formula here, dx times dx plus dy times dy, and then we're going to return distance, okay? And this is just a simple math formula, so it's x times x and y times plus y times y. So x squared plus y squared and the square root of that, okay? That's the distance formula. So now we're actually going to create a method that is super long, and it's going to actually, let's see here, choose next node. Yep, that's a method. All right, so our choose next node method, we're going to put right here before, actually, we'll put it right here. Okay. So, and this is just going to be a void because it's not, or actually it's going to be a node because it is going to return something. It's going to choose, it's going to return the next node. So, node choose next node. And this is the part of the ghost AI that is going to tell the ghost which node to go next. So this is where it's going to get interesting. So we're going to set our target tile currently to vector 2.0. So we're going to tell the ghost, or when we call this choose next node method, we're going to say, okay, well, our target tile right now is going to be 0. Okay, it's going to just be 0, 0, x 0, y 0. Okay. So we're going to pick a target tile. Let's just pick a space for a target tile. Okay. So we're not going to create the method target tile. We're going to say that Blinky's home position, let's just choose this one here. Target tile is a vector 2, so x, y, negative 14 and 4. Okay. So let's go back into here. So we'll do. Okay, so for the purposes of choosing a next node, we are going to actually have to create a target tile. And since we're not getting into individual ghost AIs, we are going to go ahead and just set our target tile equal to Pac-Man's position. So we have to actually get Pac-Man's position. So let's do vector 2, Pac-Man position. So game object. Actually, we have Pac-Man as a game object. So Pac-Man position equals Pac-Man dot transform dot position. Okay, and then we're going to set our target tile vector 2. Oops, we've already got that defined. Target tile is equal to new vector 2, and we're going to round. Target tile should be rounded. Yeah, let's round that target tile. So, or yeah, we'll round it to int. Mathf round to int. Pac-Man position dot x, and then mathf dot round to int. Pac-Man position. Oops. Pac-Man position dot y. Alright, so that gets us our target tile. Now that we've got a target tile, we're going to change our move to node. We're going to set a move to node, sorry, move to node. And we're going to set that equal to null. And then we need to get a list of neighbors, of course. So node found nodes equals new node, and we're going to set 4 because that's the maximum number of neighbors that we can have per node. And we're going to do vector 2 found nodes direction equals new vector 2 and also 4. And then we're going to do a node counter and set that to 0. So very much the same stuff that we did in the Pac-Man script to figure out where he can move next. And then we're going to say for int I equals 0, I is less than current node dot neighbors dot length, and then we're going to increment I. Okay, and if the current node valid directions I doesn't equal direction times -1. So if we're here, then that means that we found a valid direction that's not going in reverse of the current direction, okay? Because we don't want our ghosts to be able to go in reverse. So if current node let's skip over that for a second. This was going to check to see if the ghosts can move up or not. So we do valid movements. So we do found nodes, node counter equals current node dot neighbors, and then I, and then found nodes direction node counter current node dot valid directions I, and we increment our node counter here. Okay. And then after our for loop, we need to check to see if we actually have found nodes. So we go if found nodes dot length is 1. Okay. So if that happens, then that means that we've only found one node. Okay. And so we have to set our move node to just that node. Okay, that way we don't really have to do anything else. We found one node, so we can just set our move to node to that one. Okay, so move to node is equal to found nodes, and that's going to be at index 0 in the array because there's only one. So we've got our direction. Also, we're going to use found nodes direction equals 0. So we set our direction and our node. And then we check if found nodes.length is greater than 1. We found more than one node, so we have to actually find the one that is the shortest distance. Okay. So what we're going to do is we're going to say for int I equals 0, I is less than found nodes dot length, and then increment I, and so because the size of our new array is 4, we have to actually have some vector to 0 positions to fill in blanks. We can't include these, as valid move to positions, right? So what we have to do is we have to have an if statement that says if found nodes direction doesn't equal vector 2 dot 0, okay, then we add those into, right? So we get the distance, so we say float distance is get distance. That's why we created that distance formula. Found nodes I transform dot local position, and then pass in target tile. And then we check if the distance is less than, oh, we didn't set least distance. Okay, so we need to create our least distance variable. And we are going to also set it equal to something ridiculous. So if distance is less than least distance, which at first it will be because we set it really, really high. If it is less, then we set least distance equal to distance. And we set our move to node equal to the actual node that it found. And we set our direction equal to found node's direction. Okay. So, and this is going to run continuously. So if the next one is less than the current least distance, then least distance is going to get updated again with the distance that it found. And it's going to set our move to node and direction. If it's greater than, it's just going to skip over this, but it's going to iterate over all of the nodes that we found that we can move to. And then finally, after everything is said and done, we return the move to node. Okay, so that's choose next node. We're going to use that in our next method that we're going to add, and that's going to be the move method. Okay, so now that we've got all of this and we're ready to go, we are going to create a move method, okay, to actually move the ghost. So void move, and we need to call that from the update method. I'm going to call it after move up our mode update. So move. And then the move method itself is actually pretty simple. Okay. So we're going to say if target node doesn't equal current node, and the target node doesn't equal null, okay, then we're going to check if we overshot the target. If we did overshoot the target, then we're going to set our current node to the target node. We're going to change our local position and set that equal to current node dot transform, current node dot transform dot local position. Okay, so then we are going to check to see if we're on a portal. So game object, other portal, get portal, current node, current node dot transform dot local position. Current node, current node. Here we need to get the position. I may need to go back and check a couple of things here. If other portal doesn't equal null, making sure that we actually have a portal, we then set the local position of our ghost to the other portal dot transform dot position. We then set our current node equal to the other portal dot get component node. Okay. So then, done with the done with the portal, we're going to set our target node equal to choose next node. Okay, so we're going to let the ghost choose the next node. We're going to set our previous node equal to current node, and our current node equal to null. And here, if we didn't overshoot our target, so we say else, we basically increment our position, so we make the ghost move. So transform.local position plus equals, we're going to have to cast a vector 3, and direction times move speed times time.delta time. Okay, so to get the ball rolling on all of this, we are going to have to add a couple of things to the start method. So first we're going to have to add, we're going to have to set up Pac-Man. So game object dot find game object with tag, and our tag is Pac-Man, if I'm not mistaken. And then we're going to set node, so to get node at position, transform dot local position, this is right, and if node doesn't equal null, we set the current node equal to the node that we got, and previous node is going to equal current node. Okay, and that is that. So what do we think is going to happen with all of this code we just wrote? Well, first of all, let me double check a few things here. Target node. Transform, not position. Because remember, the nodes are the pellets, which are in their own little space, so we need to get the position and not the local position. Okay, so same thing with, let's see, target position, previous node transform, not position, which is right. Portal receiver. Anytime there's a position, we need to just double check and make sure. Found nodes I transform dot position. Let's see here. Direction, nodes, direction, Pac-Man position, Pac-Man not transform not position, and current node in the move method, current node dot local position needs to be just position. Node. Okay, so then we've got get node at position, transform at local position, which is fine. We're getting Pac-Man's position again. All right, so let's save that, and let's see what happens. And there are compiler errors. That does not surprise me. Oh, here, I forgot to do this. And our ghost is not moving. Why doesn't Blinky want to move? There is starting position, which has no node defined. Alright, so we need to find the node at 9.7. Let's pull at 56. Okay. So starting position. And he's still not moving. Okay, we'll figure it out. Does he find Pac-Man? Maybe he's just not moving well. No, Pac-Man's not tagged. We don't even have a Pac-Man tag, so let's add a Pac-Man tag. So let's go here and just do this. Save that. Alright, so now we've got a Pac-Man tag created. We can click on Pac-Man and we are going to tag Pac-Man with the Pac-Man tag. Alright, so let's save that. Press play. And he's still not doing much of anything. Alright. Okay. Obviously, everything is running and we're not getting any errors. First of all, let's get rid of this score debug that we're using. So that would be in the Pac-Man class. And is consume pellet. It's got to be somewhere in here. Or no, we've got that in the update method. That's where we put that last. Yep, here. Okay. So let's just delete that out. And go back into our game. And there's literally nothing here. Nothing is happening. Well, that's not what we want. Okay, so the target node is null, is what I'm guessing here. So since the target node's null, then nothing else is going to happen. So our target node being null, we need to actually set our target node So that, let's see here. Oh, well, I'm in the wrong damn, okay. So if target node, right, we have no target node. That's the problem, okay. So here in our choose next node, we're actually setting a target tile which we should be setting target node. So we'll just do this, target node. Target node is a node, though, so we need to get node at position, new vector 2. Okay, so we'll just keep this at vector 2 target tile, vector 2 target node equals get node at position, target tile dot x, target tile dot y. Okay. So now we have, oops, we don't need to do this. So now we've got target node defined. So maybe now something will happen. Shall we try? Wait. Get node at position takes 2 arguments. Oh. It needs just a vector 2. Target tile. Back to Unity. And still nothing. How wonderful. Okay. Target node equals get node at position. So let's just debug out our target node real quick and make sure so this is telling us that our target node is null. Which is extremely odd. Except for that this script is probably getting called, this script is running before the board script, so before anything else. So this script needs to run after everything else. So we need to change the execution order. So that's in project settings and script execution order. We need to go ahead and add our Ghost script, and that needs to run after Pac-Man. So first we run game board, then we run Pac-Man, then we run Ghost. Alright, so let's apply that and press play. Okay, so it's telling us that our target node is pellet 62. Where the heck is pellet 62? Pellet 62 is where Pac-Man is. So that is its target node. So the target node is obviously not null, which means that we're in here. And we obviously haven't overshot our target. Well, we have it. All right, let's see here. Overshot. Debug.log supposed to move. Okay, so according to that, we are supposed to be moving, but we are not. We are not moving. Why are we not moving? All right, so we can get rid of this because we already know that we're supposed to move. So the only thing that is going to keep us from moving at this point is if we have no direction and we have no move speed. So let's debug.log direction. And I know we have a move speed. Well, direction equals 0. Okay. Well, we didn't specify a default direction, which makes sense because I actually didn't want to get into creating the ghost house and, well, actually having the ghost start from the house, so I skipped over that whole bit. So I'm going to set direction to vector2 dot right. Okay. And our ghost is moving. And now he's going to choose nodes based on the quickest path to get to Pac-Man. See that? He's basically just chasing me around. Let's see if we can confuse him. Oops. See, he's gonna get me. He's coming. And he's gonna follow me to the portal. And the portal works for the ghost. So that's, oh, that's awesome. So this is basically the movement that we have now. Right? We've got Pac-Man moving around the board. We've got the ghost chasing Pac-Man around. And by the way, for Blinky, the ghost that I've currently got on a screen, this is basically his this is his AI, basically almost to a T. He just sets his eyes on Pac-Man and that's where he goes. He goes where Pac-Man is, so his target tile is always going to be where Pac-Man is going. So except for when he changes modes from chase to scatter, because then he'll actually go somewhere else besides chase Pac-Man. Well, that makes sense. So I think what we're going to do is we're going to leave it off here, because now that we've got one ghost on the screen, we can come back next week and fill this out so that we can get all the ghosts on the screen. And then the week after that, we are probably going to go ahead and set it up so that we can have the ghost actually try to kill Pac-Man. Well, kill, wow, that's such an evil word for a Pac-Man game. Try to end the game by defeating Pac-Man by touching him. Okay, so that's what we're going to get. And according to, did you guys see that? According to the algorithm, the ghost thought that it was going to be faster to get Pac-Man if it went the other way, instead of following him through the portal, which is, I think, pretty accurate. So that was pretty cool to see. So anyways, we'll end it here. I'll see you guys back next week for the next episode, the individual ghost AIs, so those will be fun. If you have any questions, please leave them in the comments below. If you like the episode, give me a thumbs up. And don't forget to subscribe for more awesome Pac-Man tutorials, Pong tutorials, and whatever else I come up with. I've had a couple of questions from you guys about creating tutorials for, let's see, a racing game, which sounds kind of cool, and something like asteroids, not asteroids, Space Invaders. I could probably do that. I'm also going to probably work on something similar to Galaga and probably a Gradius kind of game, something like that. So stay tuned. A lot of cool stuff coming your way. Thank you for your support. Again, thumbs up if you like the video. Comments go down below. Don't forget to subscribe. I'll see you guys next week.